Okay, so everyone ready? Okay, so first we're gonna look at like this. First we're gonna look at the dorsal view of the brain. You have this fissure in the middle called the longitudinal cerebral fissure. Right, so this part of the brain is a cerebrum made up of the two cerebral hemispheres, whereas this back part is the cerebellum. Right. So the two cerebral hemispheres here, you can see have a lot of like humps and creases and like foldings and vaginations to help increase the surface area of the brain. So all these, each little crack is called a sulcus, and the little humps between are each one is a gyrus. Okay, so this is a gyrus, this is a sulcus. The line in the middle is a longitudinal cerebral fissure. Okay. Then for the cerebellar hemispheres, here and here, in the middle we have the vermis. Here, this middle section. So sometimes it's more clear, like in this one, there's like a more clear line here for like the vermis in the middle, and the cerebellar hemispheres on the side. Okay. And then, of course, you can see the spinal cord projecting posterior to the brain here. Okay. So then we'll go to the next figure, is the ventral view of the brain. Now, normally, the brain has a protective sheet covering it called the dura mater, and that's this thickened connective tissue here. And that will be covering the entire brain. So all of these have had that removed except for this one. And so there's a few important structures that we want to make note of. So in all of these you can see the olfactory bulbs, right, on the front here. So that is also in this one here. I think this one probably has the nicest, these two have the nicest looking olfactory bulbs here. So you can see that with the dura mater still intact on this one. And then the olfactory bulbs here have two main connections. Have a lateral olfactory band here, and then you can see these kind of two like lighter lines coming in. Those are the medial olfactory bands. Okay, so the olfactory bulbs with the medial olfactory band and lateral olfactory bands. Okay. Then the next major structures are the optic nerve. So in this one that still has the dura mater intact, you can see these really large optic nerves here. But in most of the specimens that you guys have, only the base of the optic nerve is remaining. Although it's still, the optic nerves are nice and prominent in these ones, okay? But all of them still have some part of the optic nerves left. Okay, you can see where the optic nerves crisscross here, come together. That area is called the optic chiasma, like that middle of the X, and then going back it's called the optic tract. Okay, so like this part is the optic nerves, the optic chiasma in the middle, and then the optic tracts here. So this one with the dura mater, you can really mostly just see the optic nerve and the optic chiasma, and the optic tract is kind of covered up. Okay, and then we'll just use this one for the next little part. So we've got this dura mater on here. The largest of the nerves is really this trigeminal nerve. It's a three-part nerve. You can see 1, 2, and then this one actually like splits in two. So like 1, 2, 3. It's a three-part nerve. So that's the trigeminal name, and you won't really see that on any with the dura mater removed. So you can see you can reflect the dura mater, and that whole trigeminal nerve really comes up with that, okay? So that's why you won't see that on your other ones, okay? Then we have the hypophysis here, this little ball here. So the hypophysis is also called the pituitary gland. You can identify it as either one on the exam. Pituitary gland is really important for regulating hormones, and because of that it's part of the endocrine system as well, not just the nervous system. Okay, so here we have our pituitary gland. It's connected, it's actually like separate from the brain. It's like a little ball that hangs below the brain. and there's a little tube that connects it to the brain, and that is called the infundibulum. Alright, it's kind of hung on this optic nerve here. Give me a second. What happened? Hold on. Was it coming off the other way? Oh yeah, it was coming off that way, sorry. Okay, so let me tilt this so you guys can see. Can everyone see that? Okay, so we've reflected the dura mater here. So this hypophysis or pituitary gland has come off, right, and is now right here on the other side. So now, right, this is the same view that you guys were seeing here. Okay, so this little tube right here that connects the pituitary gland to the brain, that's called the infundibulum. So this is the only one of all the brains that you can actually see the infundibulum. That's the little tube that connects the pituitary gland to the brain. Okay, on the actual ventral surface of the brain here, the tissue that surrounds the opening here is the tuber cinerarium. Okay, so this is the tuber cinerarium here, and on this little brain here, I forgot, you can actually still see some of the infundibulum right here. They cut where you can like see a little bit of it there. So you've got infundibulum here and here, and the tuber cinerarium is this lighter colored tissue that surrounds this opening going into the brain. Okay. And then just posterior to that, these little round structures here are the mammillary bodies. Let me tilt that so you guys behind me can see. So these are the mammillary bodies here, whereas the tissue surrounding the opening is the tuber cinerarium. And then you can see those are just posterior to the optic tracts here. Okay, everyone on the same page? Makes sense? Okay. The next section of the brain here is called the cerebral peduncle. Okay, so this is a cerebral peduncle. There are some important large nerves that come off of it called the oculomotor nerves, and looks like those are most visible in this specimen here. So here's our mammillary bodies, here's our cerebral peduncle, and you can see two nice big oculomotor nerves coming off of that cerebral peduncle there. Okay. On this one you can see one, got an oculomotor coming off here, but not on this side. So you can see the reason why a bunch of those are missing on other specimens is all of these had to have the dura mater peeled off, and when you peel it off, look, on this one, the oculomotor nerves came off with the dura mater, so that's why they're missing, why a lot of the nerves are missing on other people's specimens. Okay, so those are the oculomotor nerves. Another important nerve in the cerebral peduncle area is the trochlear nerve, and it looks like this one here is really our best specimen. So kind of on the lateral view here, you can see the trochlear nerve. This one's nice and clear, comes off in this little crevice here on the side of the cerebral peduncle. Okay, so it's really in between, like you've got the cerebellar hemispheres back here. Cerebellar hemispheres here and cerebral hemispheres up here, and this cerebral peduncle on the side, and that crevice, you've got your trochlear nerve. Okay, so posterior to the cerebral peduncle then is the pons. So sometimes it's a little bit more clear. I would say this one has a nice clear pons separate from the others, and then this is our medulla oblongata section here. Now the important nerve that comes off of that is the abducens nerve right here. So the abducens also normally comes off with the dura mater, so you can see these are the abducens nerves on the dura mater over here. But they originate on the medulla oblongata and then go over the pons here. But this is the only specimen we have with a really nice abducens nerve. But just remember the position. So the oculomotor nerve here, trochlear nerve on the side, which you can see in this specimen, and then the abducens nerve coming off the medulla oblongata going across the pons. Okay, so then I've got pons, medulla oblongata, and then spinal cord. The only other nerve you can really see there, I mean, you'll be able to see other nerves along the medulla oblongata area, but the only one that's really clear is the spinal accessory nerve. And all right, you can see it nicely on this one. The only reason why spinal accessory nerve is nice and clear is because it's the only one that goes horizontal along the spinal cord. Okay, so all the other ones like will come up like vertically, but this spinal accessory nerve is the only other one that I want you to know. There's a few others that are after the trochlear and the abducens that are over here, but you don't need to know any of those. You just need to like skip all those and then know the spinal accessory nerve back here, okay? All right.